For these first ones, it's going to give you some information, and you're supposed to tell what method, if any, can be used to prove the triangle's congruent. We can't just make up things to add to the diagram, but we can add things that we know to be true no matter what. Bless you. So, on this first one, we're given that segment KY is congruent to segment RA, that AK is perpendicular to KY, so what does that mean?
Right
It makes a
angle.
right angle.
Where?
AKY.
Oh, wait.
Yeah, at K you have a right angle. And if AR is perpendicular to YR,
R and right angle.
R.
yeah, angle R is a right angle
And we know that AY is congruent to itself.
by
Reflexive property.
the reflexive property. So how could I prove these two triangles congruent then?
Side angle.
Side-side angle is not a thing.
Side angle side.
It's not side angle side because this angle is not between the two
Hypotenuse
sides. This is hypotenuse leg. That's why I get the big bucks. What are you laughing at?
Wait, do all teachers in public school get paid the same?
All of them? No.
Like,
Depends on
like-
years of experience.
Yeah,
And
not based on years, but like beginning salary. Do they all get like paid the same?
their first year, yeah. First year teachers all make the same amount, and then it depends on a lot of things. All right, so for this one, it says M is the midpoint of JE. So what do I know?
JM is congruent to AE.
Whoa, whoa. If it's the midpoint of JE, we need to stay on JE. Then it says JE is perpendicular to JA. What does that mean?
J is a right angle.
Yep. And JE is perpendicular to SE, so
E is a right angle.
E is a right angle.
Does that mean that JA and SE are parallel?
Yes, we could show that, but we don't need to. But yes, you are correct. Those two would have to be parallel. What else do we know here?
Angle SME is congruent to JMA.
Because?
Vertical angles are congruent.
Yes. So how can we prove these two triangles congruent?
Angle side angle.
Yeah, this is angle side angle.
Yeah.
Okay. There will be a whole bunch like this on your homework tonight, where you're just going through, marking what you know, telling how you know the triangles are congruent.
I think I like the.
Oh, I can't. I seriously can't listen to three people at once. Yes. Yeah, there'll be some like this on the quiz. Sammy, you had something to say?
I said I like the homework.
Okay. You haven't seen it yet, so
You said that they'd just be like this.
no, that's not what I
Some of them
said.
would be like this.
Yes. All right. So let's do a 2-column proof for this one. So we have our statements and our reasons. We have all this given information. God bless you.
Bless you.
Mr. Davis, I have a question. When it says that CU bisects OUG,
Uh-huh.
and since OUG isn't like a straight line, well, I know you probably don't want me to say straight line because lines are straight, but
A straight angle.
a straight angle, what does that mean?
It means it cuts that angle into two smaller angles that are congruent to each other.
So the angle OUC is congruent to angle CUG, but not
Yes,
OU isn't congruent to UG.
correct.
Okay.
So that's where we could go from the start. We could say that angle CUO is congruent to angle CUG by the definition of an angle bisector. Savannah, you had a question?
Yes. What's the difference between bisecting and a midpoint?
It's a good question. So your book doesn't do a real good job of this, but basically for what I do, midpoints are for segments, angle bisectors for angles. Basically they do the same thing. A midpoint divides a segment into two congruent segments. An angle bisector divides an angle into two congruent angles. Okay? Your book talks about a segment bisector, and then they do it like it's a midpoint every time. And I'm like, okay, you're just confusing people now. All right, so we've got one pair of angles congruent. Not enough. Yes?
Angle O is a right angle, and angle G is a right angle.
Okay, so angle O and angle G are right angles.
Would I have to split that up into two steps if I wanted to then say that angle O is congruent to angle G? Would that be a whole nother step?
That'd be a whole nother step.
Okay.
And we can do that right now. We can say angle O is congruent to angle G, but we need to give a reason for number 3 first.
Definition of perpendicular lines.
Yep.
And the next one would be all right angles are congruent.
Yes. So now I've got two pair of congruent angles. Is that enough to prove the triangle's congruent?
No.
No.
You could say that CU is congruent to CU by the reflexive.
Exactly. We could say that segment CU is congruent to segment CU by the reflexive property.
Could we use HL to say the triangles are congruent?
No. Do we have the hypotenuse congruent?
Yes.
Yes. Do we have a pair of legs congruent? No.
So I would have to have CG's congruent to CO or something like that.
Yes. But what can we use? Angle, angle, side. And I can name the first one any way I like. I'm going to call it triangle CUO. If I do that, what do I have to call the second one?
CGU?
No, CUG. And what's the reason for this?
Angle, angle, side.
Angle, angle, side.
This is a long curve.
And then once we know the triangles are congruent, then any of the pair of corresponding parts are congruent. And that's what we want. CO corresponds to CG. So segment CO is congruent to segment CG by the definition of congruent triangles. All right, let's go on to page 2 then. By the way, on this one, there is not a line up here. That's just the line on the paper. It's one of the problems with drawing with blue. So that's just not there.
Is this one going to be like the one that I asked about with the angles are the same because of the reflexive property?
No. We'll look at one like that, I think on Monday. Okay? So just to give equal time, let's do this as a flowchart proof. And again, you don't have to if you don't want to. So MN's congruent to QP, that's given. And angle MNP is congruent to angle QPN. That's given.
It's so weird that you're writing in black.
I don't write in black very often.
You should write in orange.
In honor of it being fall.
No, just orange. Pretty.
All right, so is that enough to prove two triangles congruent?
Not yet.
No.
No.
Ooh.
Yes?
NP is congruent to NP by the reflexive property.
Yes, these two triangles overlap each other and they share segment NP.
Which thing would I connect that to would be on the...
I'm sorry?
Never mind. You answer my question by putting the thing down.
So segment NP is congruent to segment NP doesn't come from either of the other parts of the given. This is just the reflexive property.
Can't you say they're congruent?
Say who's congruent?
Triangle MNP and triangle QPN.
Yes. For what reason?
Side angle.
Side angle side.
Yeah, it's side angle side. And if that's the case, then notice that angle M and angle Q correspond to one another. So I can say that angle M is congruent to angle Q by the definition of congruent triangles.
Yeah, we're done. These one charts so much easier.
Oh.
Well, if they're short, they're really. But if it's a really long proof, they can get kind of messy.
They kind of look cool on the paper though.
Yeah.
They do.
So I have an option for you. So don't answer until you have heard all the details of said options.
Right.
Okay?
I like options.
So one option is that since we're done with this lesson, we take the quiz, and after the quiz, you can work on your homework for the rest of the period. Colton voted with his eyes.
I'll stand my
The second option is that we can go ahead and do tomorrow's lesson today. It's about the same length as this one. And then you can work the rest of the period on your homework and we'll take the quiz tomorrow. Okay? I don't really have a strong feeling one way or the other, but I think some of you could use a little more practice before you take the quiz. So again, option one is we stop right now, take the quiz, go about it just like is on our schedule. Option two is we go ahead and do tomorrow's notes, which is just a continuation of stuff that we're doing here, and then take the quiz tomorrow. Okay? So, just by a show of hands, how many of you would like option one, take the quiz right now?
I cannot handle another lesson.
And how many of you would like to go ahead and do the next lesson? All right. All right. We will go ahead. I was leaning towards that. So we will go ahead and do that.
Which allows us to come in tomorrow morning for tutoring if we need it.
That's true. Could have come in this morning for tutoring. I was here.
I woke up late. Tomorrow.
doing this lesson that we're doing right now, homework is on tomorrow.
Yeah, but it's just a continuation. It's not like it's a whole, oh, you gotta learn all this stuff. It's not like that.
So no sine cotangent. Wow, tomorrow.
Is that?
You guys should learn sine cos tan by tomorrow.
There's another copy of the
Memorize the whole entire trick.
notes from yesterday. I keep finding them in various places. Somehow or another they get all mixed.
Alright, do we have to
I gotta
learn,
know the stuff on the quiz.
do we have to learn trigonometry in high school?
Yes, you're gonna learn it this year.
That's not so hard.
What?
It's not.
Oh.
It will honestly it'll be
That's what.
that's not
Well, I
trigonometry.
mean, I saw the cos.
What is that?
It's still scary.
That's calculus.
What kind of math
Cos,
trees
sin,
do?
and tan?
They're
What
like
kind of math do what?
trees do. They're like 4 answers.
Whoa.
Gee.
Wait,
Well,
what's it called? Trigonometry?
If they were once an acorn and they grow up, they say that they did, gee, I'm a tree.
So there's geometry.
Where's
Gee.
what are sin and tan?
Well, sin is when we do something wrong.
No, the
Sine
oh
is one of the trigonometric ratios, and tangent is as well. We'll learn about those
tangent
later
is
this
the
year.
Circle with the line over it.
Yeah.
Guys, I know that.
Mr. Davis.
Let me get this open, and we'll go ahead and get started on this. We're just going to be doing a couple of examples.
Do I know
Wait,
the
how
other
do you say it?
answers?
San?
Sine.
Sign. Okay.
The SIN is an abbreviation for the word. It's spelled SINE.
Why did we not keep the E? One extra letter.
Because all the trigonometric functions are reduced to 3 letters. So tangent is TAN, cosine is COS. All right, so this is just a continuation of what we've been doing. So let's see, I'm going to look at this other one real quick. I'm going to change this one. I'm going to do this. Because we haven't done enough of this type. I'm going to change this statement to simply DA is congruent to TA.
Can we do a 2-column proof?
Yeah, we can do a 2-column.
Thanks.
And then the next one we'll do is a flowchart proof.
We should make a survey on how many people like which one.
It's interesting, in my regular geometry class, they almost all want to do 2-column proofs.
Oh, good for them. Something wrong.
I used to like flowchart, now
I think
I
you did,
feel like they just look a little neater.
but flowcharts do take a while to do like all the boxes. That takes a while.
Wait, who in here likes flowcharts?
I would say I like both of them.
I like flowcharts.
flowcharts are better.
All right. So now that we've had our daily opinion poll,
Why is it called a poll?
They're polling.
Isn't
Good.
there like Paul?
no.
P-O-L-L,
Oh,
Paul?
don't start with how English words are pronounced.
Fish.
I had a friend who posted something yesterday that said, English is what happens when Vikings learn Latin in order to yell at Germans. I'm like, yeah, historically, that's kind of what happened.
You must
Wait,
be really
what?
smart to understand that one.
You do have to be. I have smart friends.
I don't get it.
All right.
Sammy's not.
So we're given that AR is perpendicular to DT. So what does that tell us?
DRA and TRA are right angles.
Now, it's nearly in stereo. So angle DRA.
That's what stereo means.
Stereo means you're getting it from 2 different sources
I didn't know that.
Wait, then why is the thing on the car called the stereo?
because it plays from more than one source.
Wow.
Wait, is it
You don't have a single speaker, do you?
Is
It's a stereo.
I always thought it was a stereo.
That sounds like
A stereo would be the steering wheel.
I know.
How do we know that these are right angles?
Definition of perpendicular lines.
Yep, definition of perpendicular lines.
Great minds think alike.
Wait, so what's a stereotype? Like, why is it called
That's a good
stereo?
question. I don't know that one. I'll have to look it up. So, is that enough to prove the triangle's congruent yet?
No.
All right. Yes?
Since, oh shoot, can I say AR is congruent to AR?
Sure.
I don't know how that would help us, but you took away the AR bisects it, so I don't know what to do.
So that is the reflexive property. Now what?
Good question.
Wait. I'm serious. I have 4 people who were talking at the same time. I can barely do one.
Prove the triangle's congruent
How?
by HL.
Side side angle.
There's no such thing as side-side angle.
Angle side side.
Hypotenuse leg.
Remember, if you don't want to be a backwards ass, don't use side-side angle.
Oops.
Okay? All right, so with hypotenuse leg, what kind of a triangle do I have to have?
Right triangle.
Have I stated that I have a right triangle yet?
No, I would say that.
Yeah.
So we need to say, no, a right triangle.
No.
We have right angles.
So we need to state that we have right triangles. So triangle DRA and triangle TRA are right triangles. That's just the definition of a right triangle. One thing to note before we go on, if this had been like an angle side or a side angle side or something, we would need to say that the right angles are congruent.
We know that.
Have we stated it? No. We would have to state that the right angles are congruent.
Wait, if this had been a what?
Any of the other ways to prove triangles congruent, side, angle, side, side, angle, side, angle. Pardon?
We would need to say DRA.
Is congruent to TRA because all right angles are congruent. Now, I have some students who are like, I can't remember when to do which, and so they started doing both. They would say that they have a right triangle every single time they had a right angle, and that the right angles were congruent every single time.
Is that wrong?
No,
It's just extra work.
it's extra work. Yeah, and what I do, if you put something extra in a proof that is true, and you can give a valid reason for it, I just mark it out. There's no point deduction.
Why do you have a duck up there
Where?
Why don't you?
at the top of your card?
Imagine not having one.
When did that get there?
Is that from last year?
It's been there all year.
I never seen this created.
All right, is that enough now to prove the triangle's congruent?
Yeah.
Yeah.
Yes. So triangle DRA is congruent to triangle TRA by hypotenuse leg. Now, we want to prove that R is the midpoint of segment DT. What do we need to say first? Yes.
DR is congruent to RT because of the definition of congruent triangles.
Okay. I would say DR is congruent to TR, just so that the corresponding parts match up, but it's not wrong if you do it the other way.
My bad.
No, it's not a problem. That's the definition of congruent triangles. Sammy?
Yes.
And now we know that R is the midpoint of segment DT. Definition of a midpoint. Remember, definitions work both ways.
What's that called again?
Biconditional.
Very use that restroom?
You may. Okay, any questions about that one?
Nope.
All right, then let's do this last one. And we'll do this one as a flowchart proof. So ON is parallel to HT. Oh, whoops, wrong ones. ON is parallel to HT. And angle N is congruent to angle H. Suggestions as to what we should do next? Yes, ma'am. Okay. Okay. We're going to need that sooner or later. So OT is congruent to segment OT by the reflexive property. Yes, ma'am.
Angle NTO is congruent to angle HOT.
No.
Oh shoot, because those lines are congruent.
Yeah, you got to pay attention to which lines are parallel.
Could it be TON and OTH?
Yes,
My bad.
it's okay. That's partly why I wanted to do this, because I wanted to remind everybody, be careful which lines are parallel. So, angle TON is congruent to angle HTO. And what's the reason for that?
Alternate interior angle theorem.
Good. Do we have enough now to prove the triangle's congruent?
Yes.
Okay. So bringing all three of these things together. Triangle. If I name the first one NOT, how do I have to name the second one? HTO. Which is why you have to be careful, although I do play around and spell things a good deal. The number of students who will fall for the, oh, that one spells not, so the other one must spell hot. And like, doesn't always work that way. What's the reason for this? Angle, angle, side. It's not side, angle, side. But now let's look at what we're trying to prove. We're trying to prove that NT is parallel to OH. Well, what will we need to know was congruent in order to know that? God bless you.
TOH and NTO.
Yeah, these two with the dots, the two you were trying to do earlier.
How are we going to do that?
Well, if the triangles are congruent, aren't all the corresponding parts congruent?
Yes. So it's the definition of congruent triangles?
Yeah, so angle NTO is congruent to angle HOT by the definition of congruent triangles.
And therefore, NT is parallel to OH.
Exactly. And therefore, NT will be parallel to OH.
Converse of the alternate interior angles theorem.
There you go, the converse of the alternate interior angles theorem. Okay, any questions?
I'll ask.
Okay, hope that didn't break you.
What?
Well, he said he couldn't do any more notes today.
Do we have a homework book?
Your homework is a worksheet.
Yes.